I'd like to introduce Jeff Skinner. He's the worldwide salesperson for enterprise blockchain for HPE.
Excellent. Thanks, Dave. Am I on here? Everything's good? Okay. Everybody can hear me? Good morning. Good morning. I am the worldwide head of sales for blockchain. That sounds like a big deal, huh? Sometimes when I hear that, I'm like, wow, that guy must be important. But it's been busy, and it's not that it's a big important role. It's an exciting new adventure for everybody that's doing something with blockchain. We're not at a loss of activity, that's for sure. So I spent 10 years at HPE and HP and Tandem and within the Tandem nonstop business. So this user group meeting and all the user group meetings and the nonstop business is still near and dear to me. I've met several of you either from a business perspective, relationship, or as a business partner in the past. I will apologize those who have seen me present this deck before. I'm going to use the same joke. I'm going to use most of the same material. There's some new things woven in there. So if you were in Dallas, some of our partners were in Dallas, there might be a couple new things at least. So we'll keep you on your toes. So I've been in this role now for about 5 months. So in dog years, that's a veteran in blockchain. Everybody that I've come across, whether customer, partner, boutique consultancy, if you hear anyone say they've been involved in blockchain for more than a year, it's just like, wow, I mean, that person's a seasoned blockchain veteran. So it's definitely an exciting time. And just to give a light start to this, I always try to start with something light, get the audience to laugh, make me feel more confident. So when you ask a question like this, and it doesn't have to be banking, everyone thinks and believes this technology is going to be transformative, and I'm among them. But when you ask who thinks blockchain is the future of banking, everyone or most people will raise their hand. And then when you go to ask them to explain it, this happened. And there's a good chance I would be one of those people that put my hand down too, by the way. So it's not always clear what blockchain is, what it does, and so as part of the agenda, I will try to explain it a little bit. So we'll go through the definition that we can all find on Google. We'll talk about some of the mechanics, some of the blockchain basics, and show how things work physically, how they come in and out of a blockchain environment, give it some context, and then talk about HPE's strategy around enterprise blockchain. So Justin walked through, if you were in his session, kind of the 3 phases of blockchain, 1.0, 2.0, 3.0 is what we call it, and we're focused on the enterprise space. So we'll show you what exactly we mean by enterprise blockchain. So if you were to Google blockchain, you get 135 million responses and results. And if you were to Google blockchain definition, you get maybe half that number. And this is most likely what would come back. So a distributed ledger technology that creates a permanent sequence, secure, continuously growing list of records, which are the blocks that are linked on a chain using cryptography. I don't know if I understand it any better after reading that. So I took a swing at my own definition, and after writing it, I still don't know if I understand it any better, but a write-only shared digital record book where each line item is time-stamped and tamper-proof. It's immutable. You can't change it. So you can append, but you cannot amend. So you can add to the chain. You can't change what has previously been recorded. Like I said, there is no shortage of hype and traffic around blockchain. Sometimes it's difficult to distinguish between hype and reality, and I think we all recognize that over time with certain other emerging technologies that have come out. A comparison that I found interesting, you have to trust me on this, these words are pretty small, but if you were to look at Gartner's hype cycle or hype curve in 2010, that's on the left, The one on the right is 2017. The one on the left is showing where cloud computing was, and the one on the right, 2017, is showing where blockchain is last year. So in very similar positions on that hype curve. All predictions don't necessarily always come through, but I found it interesting. Back in 2010, what were most people thinking about cloud? What were you saying about cloud? I think everybody, if you were, or most people, were to ask, do you have a cloud strategy? Are you evaluating cloud? Most people would say, yeah, sure. How are you looking at cloud? What do you want to do with it? And I don't know yet. That's 90% of the conversations we're having around blockchain. You know, if I were to talk to one of our customers, nonstop customers or otherwise, are you guys evaluating blockchain? Absolutely. We've got a blockchain strategy. Awesome. What kind of use cases are you looking at? What do you want to do with it? I don't know. And so that's not unusual. So when you start to get into other predictions, and this is from the World Economic Forum, so companies like Santander, McKinsey, Gartner again quoted here, blockchain technologies could reduce banks' infrastructural costs by $15 to $20 billion a year by 2022. Interesting. It's one of Gartner's top 10 strategic technology trends for last year. Not surprising. I mean, so what do they say about predicting the future? That's the easy part. Getting it right is the hard part, right? And so over time, we've seen historical technology predictions that haven't always gone well. These are a couple of my favorites, especially the ones in red. Top row in the middle, the president of Western Union at one point thought the telephone has too many shortcomings to be seriously considered as a means of communication. All right, well, you ran a telegraph company. What was he supposed to say, right? Right after Macworld in 2007, Steve Ballmer said there's no chance that the iPhone is going to gain significant market share. Anybody have an iPhone? Yeah. The last one is pretty funny. I think there's a world market for maybe 5 computers. That's Thomas Watson from IBM. So again, there's no way of knowing exactly where we're going with this, but it's clear based on the activity, the investment resources that we're seeing being poured in, that we're on the verge of something transformational. Our partners at Deloitte put out a study here just a couple months ago in June. Wanted to share a couple of their observations that I thought were interesting. Which of the following best describes how your organization currently views the relevance of blockchain to your organization? 43% called it critical, or in the top 5 of their strategic priorities, and then another 29% said it's important, but not necessarily in the top 5. So 72% of the respondents, these are over 1,000 executives from different parts of the world, different industries, view blockchain as critical to important to their strategy. This one's pretty interesting, especially from a technology provider like HPE. Which area of the company is making the decisions, the key business decisions about your blockchain activities? Split right down the middle. 39% said the business is making the decisions. 39% said IT is making the decision. So, light bulb moment. It's pretty important to have both in the room when you're talking about blockchain and how you're going to go forward with it. But this one takes a look at the hiring activity in blockchain. Worldwide, we selected seven different countries, so Canada, China, France, Germany, Mexico, the UK, and the US, left to right. I think it's noteworthy to see that Canada is ranked 3rd on this list in terms of hiring activity, and not necessarily surprising if you're following the industry, even generically or at a high level. Canada, and especially this region, Toronto, has emerged as really a blockchain center of activity, of innovation. You've got Vitalik Buterin, who was the founder of Ethereum, who's from Toronto. There's the Blockchain Research Institute based in Toronto, which at any given time has 70 to 80 proof of concepts or projects being validated on blockchain. And there was a project generated by I think it's called the National Research Council of Canada, to promote transparency in government-awarded contracts. So, and that's, I think, in pilot today. So I think most governments could probably use a little less corruption and transparency. So we'll see how that one goes. So, yeah, Canada is, again, third on that list. Top one is China. So 86% response rate there for China hiring in the blockchain space, which if you looked at intellectual property in terms of patent filings and or patents already held, the top 100 in the world, patent holders, 56 of them are in China. So not surprising to see them doing the most hiring and the most focus. U.S. incidentally is at 24%, so last on the list. So slower to adopt than a lot of us would have thought. So more activities sort of showing, again, kind of the reason for some of this hype. You can look at the top 5 patent producing countries or regions in the world: U.S., China, EU, Japan, and South Korea. We're not through 2018 yet, but you can see the numbers continuing to go up, and especially in, from 15 to 17, you saw a real exponential jump in the number of patent filings. Again, that everyone does stuff with their patents. Not all patents get granted, but you can just see the level of interest and activity being shown. And there are certain listening technologies out there that can pick up on keywords during company earnings reports, whether quarterly or annually. And last year, there were over 4,500 mentions of blockchain when companies reported earnings compared to the year before 1,300. So more and more CEOs, CFOs, COOs, and others reporting on those calls are mentioning blockchain as critical to their future, critical to their growth, and to their focus. Again, here's where people that have heard me do this presentation before have heard these last 2 bullets, but it's too funny to me to take them out. So Long Island Iced Tea Company, anyone hear of them? Not too hard to figure out what their core business is, right, just by their name. They based in Long Island, New York, changed their name, their corporate company name, to Long Blockchain Company. Their stock went up 350%. The SEC didn't really love that move. It turns out they had no either experience or real plans to even evaluate blockchain. They just changed their name. So not all is well that ends well for them. They were in April delisted from NASDAQ, and they're trading less than $1 right now. So hopefully you short traded them and got out at the right time. Chanticleer Holdings is a restaurant holding company that owns Hooters, one of Naveed's favorite places. They announced in one of those earnings calls, they announced that their customer loyalty program is going to be based on blockchain. They're moving forward with a blockchain strategy. Their stock went up 50% the next day, just based on that. And in that same call, they missed their earnings, and their numbers still, their stock still went up. So interesting. So now kind of turning to some of those mechanics and a little bit of blockchain basics and showing how it actually works. So how do we interact with blockchain? This is a fictional example. Those who know me know I would never sell my Cubs tickets to the playoffs, but let's just pretend that I put my 4 Cubs tickets for Game 1 of the National League Division Series, hoping we make it. Hopefully, we put them out on StubHub, $250 each. I get an email from somebody named John saying, "I'll pay you $1,000 for your tickets. We can both avoid the StubHub fees. Just email me the tickets to the address above." No frickin' way, right? So I don't know John. I'm not going to send him my tickets with no guarantee of receipt of the money. So thanks, John. Hope you find other tickets. Let it ride on StubHub. Lo and behold, we find a buyer at the price that I was looking for. It got transferred into my PayPal account, all is well in the world. So I just trusted that experience more. I've done business with both StubHub in the past, both buying and selling, and I've had a PayPal account for a number of years. And so why did I trust experience more than good old John? Because StubHub and PayPal in this example are what we call intermediaries. They're trusted. They provide you with a single set of facts for each transaction. And those are really the two things you need. You need trust and a single set of facts for every transaction that you engage in, whether it's through your banking relationships, with your government, regulators, business suppliers, what have you. Those are the two basic fundamentals you need in every transaction. So what does this have to do with blockchain? So blockchain does that. It establishes those two things, trust and a single set of facts, so automatically. And it does it through what we call a distributed consensus mechanism. And so that at the heart of the mechanics of blockchain is really what drives the bus here. And so let's explain what that means. So we're talking about blockchain 1.0 here. So person-to-person, we'll put out a decentralized peer-to-peer network with a few different nodes, 6 different nodes out there. One node can fall off, the network still performs just fine. We can continue operating it as usual. Blockchain, each one of these nodes has a ledger associated with it. Each one of these nodes has the same ledger associated with it. So you can't get through a blockchain presentation without saying Bitcoin, so we're going to pretend these are Bitcoin. Okay? So is there a transaction showing that A paid B 1 Bitcoin? There is. But unlike that last example with StubHub and PayPal, where those were really the only two, and maybe my own ledgers that mattered in that scenario, blockchain, everybody on the network, everyone's ledger has to reflect the same thing. Everyone has to have the same visibility for the same information. So we see that transaction happened, but do we also see it across all of the other ledgers in the network? In this case, yes, we do. They have to be in the same chronological order, which in this case they are. They have to have correct digital signatures, the right public-private keys associated with them using cryptography. So in this case, we can validate that, yes, A paid B 1 Bitcoin. Okay, so that's just a real, obviously, basic blocking, tackling view of how things look in a blockchain environment. So how does information actually get in, new information get into the network? So let's say C wants to pay A 1.5 Bitcoin. So each major blockchain platform, of which there's really 3 emerging right now. So it's R3, Corda, Ethereum, and Hyperledger are the 3 most prevalent blockchain platforms out there. There's others that are certainly emerging, but those are the top 3 today. They each have validation nodes associated with them. They call them different things, but they, well, in Ethereum and in Bitcoin, they call them miners. Hyperledger, they call them peers. And in R3, they call them notaries. But they validate a little bit differently, but at the core, they do basically the same thing. They verify identities. They ensure that there's not a double spend occurring of that same 1.5 Bitcoins. In some cases, they can execute code, and they can also enforce business rules along the way. So once that first node validates what happened, or the first notary can say, yes, I validate the identities of those people, then it gets populated out to the rest of the network, gets populated into each and everybody else's ledger on that network, and away we go. Everybody has visibility to it. So this, again, is what we are calling blockchain 1.0, so open, permissionless blockchain networks. So thinking of, again, Bitcoin, Ether, other cryptos, really the first mover in blockchain was this environment. So that's not HPE's focus. So our focus is in these next 2 areas. So blockchain 2.0, which is, Justin explained it, enterprises transacting with enterprises, business to business, over what we would call a private or permissioned networks that need things like mission criticality, privacy, scalability, a lot of the things that Nonstop has as its core, at its core. And then blockchain 3.0 is quickly emerging as well. That's, we call it things transacting with everything. So sensor-based computing, the wearables that a lot of us have for healthcare purposes and other reasons. So those two, the last two pieces are 2.0, 3.0. That's our HPE's focus. Blockchain for the enterprise. That's how we define it. And with that comes a whole set of unique requirements, both from a functional and architectural perspective. So functionally, these are transactions, obviously, that are happening between parties and people, entities that know one another. So privacy is important. These enterprises often operate in jurisdictions where rules, regulations, compliance requirements differ. Data sovereignty could be an issue, especially in financial services. And architecturally, these are the things that speak to Nonstop's sweet spot, right? So speed, scalability, availability, all of those things. And we're seeing more and more of a need of working within a portable environment. So being able to take that same application and distribute it into a hybrid operating model, and that is also a key part of our strategy that I'll touch on here in a moment. So most of the activity we're seeing today in the 2.0 space is still very early. Cryptocurrency, again, 1.0, that's in production, has been in production. 2.0, we're seeing a lot of prototype, a lot of proof of concepts, a lot of false starts, quite frankly. And I'll explain some of the reasons why we think that is in a moment. So almost 80% of all the activity, again, is coalescing around those three platforms I mentioned, R3, Hyperledger, and Ethereum. There are others like Digital Asset and other smaller ones that are quickly gaining ground. And in terms of industry, it's no surprise that banking, securities is leading the way in terms of the majority of the traffic. But I will say the last, again, it's only been 5 months, but within the last month or so, almost every conversation we've had has been within the supply chain environment for whatever reason. And it's a natural use case, and I'll explain. I've got an example of one. So manufacturing, government, they've all got use cases identified. So at the end of the day, blockchain is about use case. I think most of us that have researched it understand that. It's just kind of taking that use case and doing something with it. According to Gartner, this is Gartner's number, 80% of the current blockchain projects are going to go live this year that are in pilot or POC. Why do we think that is? There's a lot of reasons, really, but and it could have nothing to do with the POC itself. We've seen a lot of successful POCs. We've seen a lot of teams prove proof of value in a POC, but there's a couple things that haven't really been considered. So as we've transitioned from a globally, digitally integrated enterprise to more of an ecosystem business model, which, as it says here, is a symbiotic community focused on specific business outcomes. You need the ability to rapidly integrate or disintegrate competitors based on a customer-by-customer basis. Again, we've identified significant value in a lot of these sort of environments. We've proved out some successes, but what we're seeing more and more is that companies that have invested resources and time into blockchain, that just proving that you can do something isn't good enough anymore. We want to see it in production. We want to see measurable ROI, and that's not an easy challenge to most. You look at the ecosystem, it's got governance requirements, regulatory and compliance concerns, privacy issues, and we haven't even touched on what the customers' expectations are. Our end user customers, things like functionality, usability, all the table stakes things that have to happen and occur within an application, and haven't even considered those things in some cases. And for this business model to work, it's our point of view that you need an ecosystem IT operating model surrounding it. And this is the piece that a lot of the POCs have ignored in what we've seen. So POCs get off the ground on a laptop somewhere, and no consideration from after the success. How are we going to move that into production? That's where we come in. And so it's our point of view. Every proof of concept needs two things. It needs proof of value, and it needs a clearly defined class of service. And so we define class of service as a set of technical attributes, business dependencies, and a governance model required to support the application business outcomes. And so when you look at class of service, and this is a typical, what we would see as a typical customer journey as we meet with existing customers or prospects. So we kind of have it divided into the exploratory phase, where you're trying to figure out what use case you even want to try, or help define a use case. Some customers don't know what they want to even try. We meet with some customers like Credit Suisse in New York. First time we met them, they had 15 use cases already identified. We got there and they said, here's our 15 use cases. We want these 5 on Corda, these 10 on Ethereum. Go. You know, that's one extreme. You know, and then we go somewhere else, and we have to go through kind of the level of education or background on blockchain that I walked through previously. So once you have the outcomes in the business use case, or the use case defined, you move into that POC phase, and that's where those functional requirements come in. And that's where the platform could be identified, whether Corda, Ethereum, Hyperledger, again, any of the others, and you move into POC. And that's, again, where we see customers get stuck. So you go 90 days, you show great results, even using real data in some cases. All right, good, now we're going to move it to production. And then they hit a roadblock because they did not take into consideration the production operating environment. So next logical question could be, how do I figure out what class of service I need? And how do I deploy it? And so this is a new development from us. This is currently in our labs being worked on. We had a prototype of this at HPE Discover, our big end user event in Las Vegas in June. We're going to have an enhanced version of this at Discover in Madrid coming up in November. But our blockchain, it's called our Blockchain Catalyst platform. And so it's designed to accelerate, simplify the provisioning class of service matching. And the goal really is to take days of deployment time down to hours in some cases. And so you look at the section on left here, that kind of was the first area of the last slide I showed. So, you know, you come up with the business technical requirements, you back into the platform you want to use, what operating model you want, and then from that, we call it a class of service matching engine. So what are those requirements? Put into an algorithm that's being developed that's going to be our IP in our labs right now. It's a class of service matching engine. And so from that, you move that into a hybrid operating model, and I'll explode that last piece so you can see what I mean. So I mentioned the hybrid architecture before, hybrid ecosystem. So just like everybody's operating environments, not every node needs to be mission critical. Some do. So for notary nodes, nodes that need a 360-degree view of the customer, things that are at the core of your business, nodes that have the privacy concerns, the data sovereignty concerns addressed. Those are the ones that are mission critical. Those are the ones that should be run on-prem and should be run on nonstop, quite frankly. You move to the right, you have other nodes for your customers, for your financial advisors, for maybe some dedicated regulator nodes that might have variable levels of compute, networking, storage, what have you, need to be dialed up or down at any given moment, and flexible consumption models. Those might be more targeted, more appropriately for a private cloud. And then last on the right, you have kind of the public cloud instance where you could have transient nodes where customer suppliers come and go at any moment. And so that is probably better suited for the public cloud. And again, being wrapped with the right consumption model, being able to dial up, dial down at the right time, whether there's sales promotions, busy periods of the year, all of those things we view as enterprise blockchain and a hybrid ecosystem. So we've developed a few ways for our customers to consume it. Justin mentioned our mission critical DLT solution, which is our hardened offering in this space. So with all the hallmarks we know from being around Nonstop for so long, all the scalability, fault tolerance, all the things that most likely would be run on-prem. That is the MC, what we call MC DLT offering. We have a hosted version of this running. I don't know if Justin mentioned this, but the hosted POC lab. You mentioned that? Okay. Okay. So for customers that want to get started quickly, we have not only the ability to help identify use cases and get you thinking in the right direction, we also have at our Nonstop ATC in Fort Collins, we have a server dedicated to this environment, a proof of concept lab that you can gain access to and begin testing on a Corda environment, as soon as you're ready. So we're offering that as a service. We also have developed an Edgeline, what we call an Edgeline developer kit. So it's a smaller Edgeline server also running Corda that you can put into data center, kick the tires, boot up a synthetic ecosystem if you want, and see how it might look and feel, and you can partition it so your innovation team can have different use cases running simultaneously. So I mentioned Credit Suisse, they have one of these right now. They're looking at 3 different use cases, 3 innovation teams working on it at the same time, all running Corda, going really well. And so we also have come up with reference configurations on Synergy for composable computing and Superdome Flex, blah, blah, blah. We only care about Nonstop in this room, right? Okay. So at the end, it's our point of view, and I think it is a differentiator, especially with the catalysts that we've offered. We're still developing, helping you define that class of service, the operating requirements that you're going to need to take something into production. We've got the services team, our Point Next organization, organized to help you go through some of those iterations if you need the help with use case business outcome development, or if you've already done it and you need validation, we can help with that too. We've partnered with all the right people so far. We mentioned our 3 a lot. Our Corda product is running on Nonstop for a reason. They're the one that thought about enterprise class, enterprise grade blockchain from day one. So they were born out of the financial service industry. So they were 7 or 9 banks got together, invested in R3, created Corda. So they are aware of all the things that you need to be: scalability, fault tolerance, privacy. All of those things were taken into consideration from the ground up. So that's why we have partnered with them initially with their Corda product. We have also partnerships with Ethereum, which is probably the bigger name brand out there in blockchain. If you were to do research, more traffic is definitely on Ethereum. Not surprising. It's similar to how you would think of Nonstop and then industry standard servers. I mean, there's way more industry standard servers in the world because they're disposable in some cases, where mission critical is going after a particular niche or particular space. So a lot of Ethereum traffic. We're part of that alliance. We're also doing work with Hyperledger. Digital Asset is another one whose logo is not on here, but started. We were just with them in New York last week. Started by very bright people from Swift and JPMC. They're, I think, going to quickly emerge as another one that'll be in the top 4. So there's a big 3 today. I think the Digital Asset will be the 4. So between all the partnerships, the stuff we bring to the table from Nonstop, the stuff we bring from Point Next gets you off the ground and running. I think our enterprise blockchain strategy is better than anything I've seen. You know, IBM has got a head start on things just based on where they've been in the industry. Their focus is on Hyperledger exclusively, and they will really promote their blue mix of products, and they will want everything running on IBM, which I don't blame them. So our approach is more open and more flexible in terms of blockchain platform and operating model. And so, you know, just like everything else, you should look at, evaluate as much as you can, but I think our story is going to stack up pretty well. The last slide I had. So I'm definitely willing, able to take questions. If I don't know the answer, I'll make something up that sounds smart. Or Ken will follow up and answer it later, I'm sure. Any questions? Yes, sir.
Blockchain had a lot of
mm-hmm. R3 in terms of volume and yeah. Yeah, absolutely. Those limitations are still there. So you will not see blockchain replace a payment authorization stream anytime soon. So what we would look at in a payments environment, which obviously is pretty relevant to the nonstop community, we would look at more adjacencies instead of within the transaction flow. So settlement, so batch settlement doesn't have to happen on a batch basis. It can happen in real time. And that's maybe an area for blockchain. But payments is one of the areas that is emerging, you know, and we've talked we've had Keith Moore isn't here, but we've had day-long sessions on how can we embed a Corda offering into a payments infrastructure. And until those transaction numbers come up and the performance improves, it's not going to get involved in that stream anytime soon. Yeah.
So there are use cases.
Not use cases within the payment transaction authorization flow. Yeah, so it's kind of surrounding that, and for good reason. I mean, unless you want something that can do, you know, one transaction a second. I think. Mm-hmm. Yeah. Here, let me. Good. So, kind of move these to the back in case people started asking questions. So again, every vertical has got use cases, whether or not they're going to emerge into production. So healthcare, I think if, you know, we got to a point, so we were meeting with Merck Pharmaceuticals, and we're going to have a follow-up with them with Merck and Cerner. So something I didn't mention, a lot of the blockchain activity today is focused around the consortium model, consortium idea. So for really to gain traction, companies and partners, sometimes competitors, really have to come together in a consortium model. And so for healthcare, especially in the U.S., it would certainly be nice to have control over your own health record and being able to take that and have it portable to and available to every healthcare provider that touches your information, be it pharmacy, benefits management, hospital provider, insurance, you name it. And so there's consortiums built around that idea. Those players don't cooperate very nicely with each other. And so, you know, blockchain is about, in some cases, eliminating intermediaries. And in some cases, you're talking about eliminating companies or businesses entirely, you know, that act as intermediaries. So there's some pushback on cooperation. But healthcare, wearables, you know, just that being able to track that information back into an environment that goes to your insurer, make sure or your life insurance, your health insurance, your provider, all those things can be centralized or are decentralized into all those different pockets, as an example. Sure. Paul. Mm-hmm. Yeah. No, the regulators, I think, like it because it adds a layer of transparency. In R3, for example, they have several, I don't know the exact number, but several regulators as members of their consortium. So the regulators, anything you can do to create more transparency, they're all for it. You know, and that's something where we envision banks, financial markets having dedicated nodes for that purpose, specifically for report out for regulatory compliance purposes. Yeah. Ron. Yeah. So, you know, basically everything you see here, you know, so supply chain and manufacturing, like I said, I think is where we're seeing most recently the most new activity, I should say. A couple other cool examples recently were manufacturing, but within the automotive vertical. So, who is it? Volkswagen and Renault in Germany are working on a POC now to take usage data, so mileage, maintenance, all of those things, and putting it on a blockchain, because in Germany, over 1/3 of all used car sales have odometer fraud. And so they are looking at eliminating that by having everything placed on a blockchain. Toyota their innovation labs are working on a program, and HPE is working with Audi on this, but Toyota is doing it on their own, where you put like a micro server in the trunk of your car, and Toyota can get, you know, the readout of that Prius and see where cars accelerate more, where there's more brake activity, and just all the diagnostics that are surrounding that particular car, and they're using that information to populate their machine learning algorithm for autonomous cars that they're eventually going to release. So all of that will be pretty cool to see when it comes into production, and they're paying that driver of that Prius for that ability to use that information. So if you're driving that Prius, you get $60 a month back for Toyota to use that information for their research. They have it set up so that $60 goes right to your car. So you're almost incented to do it. Yeah, of course. Yeah, I mean, and there's plenty of examples of that. I think that the Toronto version of one of those research labs is one of the best, for sure. And that's why Toronto is, like I said earlier, emerged as and recognized as a worldwide innovator in blockchain, for sure. Mm-hmm. Yeah. But you didn't hear it. So that similar to what we have for the food, tracing the product origin for food, seems like a natural for the pharmaceutical industry as well, in terms of counterfeit drugs or other things that could be deemed unsafe or expired drugs being resold on the gray market. And that's one of the things Merck brought to our attention when we were with them, in fact. They can afford it, for sure. Yeah. So obviously it's a cool space. What else do I have here? So music, digital rights. So there's an artist named Imogen Heap who created her own site, music site, so you can download music directly from her and eliminate sites like Spotify or iTunes. And so for every time you listen to one of their songs, a penny or two goes back right to the artist. So I know we're all very eager and anxious to put more money in the artist's pockets, right? But at the same time, it's you think about how many times you listen to a song for it to get to the $2 level. I mean, that's 40. I don't know how many times. Was that 200 times you'd have to listen to that song? So anyway, another innovative approach. There, travel. There's a company B-Token is an Airbnb competitor. I think we'll see emerge. Airbnb, if you've used them, it's great. They've got a lot of infrastructure, though. They've got a lot of offices, a lot of employees. B-Token is very small, very, very modest in terms of employee count. I think they've got 30 to 40 employees. But again, you buy some of their cryptocurrency called B-Token, so you exchange your currency for one of their tokens, and you can go online and rent one of their properties. So always innovative ways that people are looking at it. What else? This is an example ID 2020 Alliance that I think is pretty cool. Accenture is really driving this one worldwide. So there's over 1 billion people on the planet that don't have a form of legal identification. And so this project is to create digital identities for those people. And if you think about all the things you need an identity or an ID, a formal government-issued ID to be able to take advantage of, even welfare programs or getting a driver's license. I mean, all of these people have just been kind of hamstrung, and now with a digital identity, they'll be able to do some of those things. And while I'm at it, while I'm back here, so again, you guys, the dad jokes. You guys ever go on YouTube and look at dad jokes? So if you like really bad, dumb humor like I do, Will Ferrell and Mark Wahlberg have this thing called dad jokes, and they tell really bad jokes to one another. And the other person laughs. The guy gets a point, so they play to 10. And so if you read, I mean, this is terrible stuff. And so it just means I've been spending too much time, the fact that I find this stuff funny. But first one, would you like sauce with your steak? We have loads of sauce. Oh, okay, sorry, I lied. We have only one sauce, blockchain sauce. The single sauce of truth. Terrible. But it made me laugh. Anyway, so I'm risking going into rambling mode here. If there are any other questions, please grab a hold of me. Happy to talk to any of you, and thanks for your time this morning. Appreciate it.
Okay, thanks, Jeff. That was great. Another speaker coming up now. Very interesting. As a user group, we do try to get customers, users, to tell stories about what they're doing in their environment. And it's quite often challenging for us to find somebody willing to come forward and explain a little bit about what they're doing. But as part of our theme this year, sort of what's current with Nonstop today, I think there's a lot of modern activity going on. And Dave Wiseman from TELUS Health has been doing a lot of very interesting development work. And so I asked him if he'd be willing to come forward to the user group meeting and do a presentation. So he said yes, he would. And he's come up with a presentation that he calls From COBOL to Cucumber. And I think you'll find it extremely interesting. Take it away.
Take it away. Okay. So yes, COBOL to Cucumber. When I started with TELUS, we were a COBOL shop only, and today we're looking at technologies like Cucumber to further modernize our development, speed up our development, and so forth. So my goal in this presentation is to give you the progression of our development over the course of the last few years, and to provide some of the tidbits of learning that we've picked up along the way. So this press So first, a bit about myself. So I started in a real-time control space in '86. We were dealing with C assembler, embedded systems, and this is my tie-in to Nonstop or Tandem. So I sat beside guys who had big terminals with a notepad on the side. That's all I knew about Nonstop at that time. And if anybody knows Greg Mortimer, he was one of those guys. So my first Tandem exposure was with Bell Canada in '88. And then I had a long stint at the RCMP where I was a consultant for the CPIC, which is the Canadian Police Information Center. I managed to do a year at CIBC, lasted a whole year. And then at 2007, I've landed in TELUS, and it's been a good place so far. So this is basically the chronology of what we've done from 2007 to today. And so, as I mentioned, we were COBOL only, and then we moved into I started developing SOAP3 web services. Looking back at the dates, it looked like it started about 2009, but I think our first production web service was 2011. And so we did a bunch of SOAP3 work for a bit. Then we started to look at Java on the Nonstop. I think by that time we had a reasonable version of Java. It was Java 6. So I think before that there was sort of a reluctance to develop in Java 4. I think it was before that for the previous system. And then so we moved into open source web service development in 2013, 2014, and then Java Pathway servers in 2015, SOAP 4. So now we're up to today. We're looking at SOAP 4, and then also Cucumber and this continuous integration. There's been some references to continuous integration and continuous deployment in the previous presentation. And the reason I have a question mark on SOAP 4 is because we really aren't sure what we want to do with our SOAP 3. So SOAP 3 is end of life, and so we have to go into we have to find a solution for these SOAP 3 web services. And Cucumber and CI is a very big topic. And I'm just going to give you an idea where we're going with that today. So in the beginning, we had a project where we were replacing a remote server call technology for our paper reimbursement infrastructure, so people can submit paper claims. By the way, I should mention that what we do is adjudicate drug claims from pharmacies. And one of the forms of submitting a drug claim is a paper claim. So this infrastructure had reached end of life. The natural choice at that time was web services, and that meant for Nonstop, it meant SOAP 3. And as I mentioned, we deployed our first web service in 2011 and went on to develop 16 more SOAP 3 services. So they took on quite nicely in the environment, and people recognize that there are all of these repositories of data on the Nonstop, and now you could link them to your Java applications that ran outside of the Nonstop. So I'm going to go over just an overview of what SOAP 3 is, and the reason I'm doing this is because a lot of stuff in SOAP 3 is used today. It's used today in SOAP 4 and so forth. So it's OSS-based. SOAP servers run under an ITP web server, which is a pathway. They use this TCL language for their file configuration or tool control language, Tandem tool. So that's a little unique. The SOAP 3 web services, as I mentioned, support the C++ user exit, and this is very similar to if any web service environment is very similar to what's called the servlet life cycle. You can branch off into your own code, look at stuff, come back to the processing chain of the web service. So as I mentioned, ITP web servers has been consistent in all of our development, all of our modernization, all of our SOAP web services. It's been a constant. So SOAP 3, they're server classes. The SOAP servers are server classes. SOAP 4, they're server classes. NSJSP containers are server classes. Some of the nice things you get out of the ITP web service is that you can see all of the HTTP requests coming into your system. It shows you the time and so forth, and the amount of traffic you're getting. It also shows the status, like was it a successful HTTP request or did it fail? And so that's one of the first places you go to look if you get questions about what's happening on top in terms of web. We built out these user exits to do a bunch of stuff, but they're good for writing custom logging. So you can dissect your XML message or your IPC buffer, and so you can dump that out onto these console logs. So those are one of the really values of some of the user exits that we did adopt. SOAP 3 servers are fast at starting, so you can have like a max servers 2 and num static 0. If there's a demand, it'll start up very fast. We've had a few issues early on, but no real showstoppers. But when you go to the Global Nonstop Support Center, and I'm sure a lot of you guys have experienced that some of the issues you're going to encounter, they have a very difficult time in getting a definitive answer. So that's been a theme with some of the stuff we've been doing. Having said that, we basically ignore these web services now. They run in production, and there's really no real involvement day to day. This is an example of a ITP, the pathway environment. So I've got in the red here, I've got a couple of SOAP servers, and then the HTTP listener. So this is, again, because this is common throughout all of your web service development, your ITP web servers will have a HTTP listeners. This is sort of a look at what the TCL command language looks like. And the reason I put this one up is because it is a pathway server configuration. And so you can sort of see, you can see the familiarity of a typical pathway configuration. This is, I left this slide in here. It just basically, this is the SOAP 3 configuration file, and the important stuff is logging. It tells you, this is where you indicate where you want your log files to be written, SOAP error and SOAP trace. So what I mentioned, when we do in our user exits, we have these custom messaging. It'll go to that CGI SOAP .trace file. Development. So this is basically, I'm going to give you a rundown of development of SOAP web services. And again, this is common, as I mentioned. So you define your request response structures in DDL. You create what's called a service definition file, which is an XML file. Then you run this SOAP admin CL command against the SDL file to create the web service. So what you're going to get is a WSDL document. And if you indicate that you're including user exits, you'll get this make file that allows you to compile and link your code to the SOAP server. Finally, well, you have to add, the next step would be to add the URL mapping and the SOAP server to the web service config file. So the ITP web server is going to read this config file to find all of the mappings to your web services. So the first part in blue is the URL mapping, and the next part is the actual server configuration. So you're telling it that common server attributes, that's basically going to do your num static, your Mac servers. So I'm kind of dwelling or spending a lot of time on SOAP 3 here, but these DDL, the SDL, the SOAP admin CL are constant. So as I mentioned, we are doing this today with NSJSP web services. DDL. So this is basically a sample DDL. So this would be the request message. Everybody's familiar with DDL. The only thing with the DDL is that you can include these annotations for the program, that the SOAP admin CL program that's going to create your WSDL document. So you can include these annotations, and it will control or dictate how that WSDL document is going to be created. In this case, it's going to say you do not have to include these disable flags on the inbound message. Essentially, is what that's going to tell it. So you can have either include it or not include it. It won't violate the SOAP parsing. This is an SDL file. I think this is a version, a SOAP 3 version, because I just wiped it from one of our directories. But the stuff in red is really the main thing. You include the DDL definition, the request and response definition. So that's a main takeaway here. There's a lot of other fields here and information that I would bore you to pieces if I went through that. So now a little bit on the WSDL. So as I mentioned, the SOAP admin CL command is used to generate the WSDL. And then once you have a WSDL document, you're going to hand that over to, or your client is going to reference that WSDL document by browsing to that URL that you've provided, and they will then, those applications will then, they consume the WSDL, and then they can create all the Java classes that are needed to communicate to that web service. So ultimately, the goal, the thing here is with the WSDL document is to create Java class that you can populate. You pass to the web service framework, and it will convert those objects or marshal those objects into an XML stream that's sent to the destination. So one of the main things you'll see in a WSDL document is the location. So that's one of the most important things about passing the WSDL document to your peers for them to consume. So there's also, so when you run the SOAP admin CL command, you're going to get like 4 directories. There's an XSD, an XSD directory, and in that directory you're going to see if it's going to dictate your validation rules. So the incoming XML will validate against that XSD, and I have this SOAP message type document. I was looking back and saying, how does the XSD validation actually take place? And from what I read is, and we have all of our document types, or we have document type for all of our web services. but just specifying a document type triggers this XSD validation. There's the alternative is RPC, and it supposedly turns off that validation. So as I mentioned, we did go down the avenue of deploying or adding user exits. And you got to wonder why you did this in the first place at some time. But what we wanted to do is we wanted to add the validation. So we had if you're taking these web services and you're replacing or mimicking your COBOL interface. So COBOL, you basically you lose your COBOL validation. So this is where we added that level of validation, and so that custom validation was done in the user exit. You can, as I mentioned, you can add tracing, so custom tracing, so great for watching, debugging, so forth. We also did some auditing of transactions going in and out, just a simple view of the traffic going to that. That's C++. Actual C++, yes, but it can evolve to just C program. I'm not a C++ programmer. I never want to be a C++ programmer. That's sort of the end of the discussion on SOAP 3. And now I'm going to fast forward, jump ahead into my timeline today, but I want to sort of continue this nonstop SOAP conversation. So as I mentioned, we stopped SOAP 3 development in 2014. As I mentioned also, it's been very low maintenance. And the SOAP 3 thing here is that it's not supported on nonstop SOAP or nonstop X. So nonstop SOAP 4 is a port of Apache Access to C, which is quite a bit different. SOAP 3 to SOAP 4 migration is fairly straightforward. Now, if you were to talk to our folks in the Ministry of Health, they would probably have a very different story, how difficult or how painful migrating to SOAP 4 on the X platform has been. And, SOAP 3 to SOAP 4 migration with user exits is not straightforward at all. And I have a sad face there because this is what we're dealing with right now. Even like there's elements that we're using in our SOAP 3 web services that they're just simply not available. And we use this zip parse command to mimic a ping. So if you send in a certain request, it'll format a certain request. It'll detect that and say, okay, just bounce back a response, and don't even go to the COBOL or to the back-end server. So this is our nonstop SOAP X migration option. So initially, I was going full force or considering this 3 to 4 as the natural path, in spite of the other team's experiences, in spite of the unsupported elements, and even in spite of the major differences in this servlet lifecycle part or the user exits, completely different, scary different. So I know there's probably not a lot of people that have developed SOAP 3 and user exits, but if you have and you haven't looked at this yet, it's a little shocking, to say the least. So we had plenty of lead time to do this. Like, we're not moving off the current Itanium until, I guess, July next year or something like that. So I thought we kind of jump on this, but the moment I started, there was errors. So for then the big one is that SOAP and our pathway environment are incompatible. It's astounding that would be the case, but it is the case. Because our system in staff are looking after not only our system but the ministry system, they were not interested in upgrading a major piece like Pathway for us at this stage in the game. So we're stuck. We're basically now, we cannot go forward until we get an Xbox with this kind of approach. So now I'm considering that we port all of these services into our Java environment. So we'll talk a bit more about Java, but my current direction is to build out a POC to prove that we can provide a transparent solution. So the idea is that we have all these clients that are accessing these web services. We're going from SOAP 3 to SOAP 4, or SOAP 3 to another solution, but we don't want to break their environments. And then this is a major challenge. And I was talking to Phil last night about this. So we're going to talk some more. Okay, so this is my hindsight is 2020 on non-stop. So how do I diplomatically say this? But so if I was approaching this and my advice would be, if you are comfortable with Java on the nonstop, look at that as an approach for developing web services. They won't, you most likely will not be stuck at the end of something coming to the end of life. And if you can't do that, if you're not comfortable with building out a whole Java shop in your nonstop space, you need to talk to some of the third parties, I'd say. So at least ask them what their solutions are for this kind of thing, because frankly, I look at when you're looking at nonstop SOAP 4, it almost feels as proprietary as nonstop SOAP 3, and so there's to the dead end you're going to hit with that product. Well, just my opinion. Okay, so enough with SOAP 3, SOAP 4. Now we're into open source, and it all started with 3 letters. And so we were reimagining. So in 2013, we had a project to reimagine that same paper reimbursement system. So that's our first SOAP web service that we built on SOAP 3. Now we're looking at it again. We're adding. We want to do a lot more with this system. At the same time, Phil and I were talking. Phil Lee, if you haven't met Phil, please stop by his booth. Here's Phil, and have a chat with him. Anyway, so Phil's an insightful guy, and so he said, "Dave, look at CXF," and that's all it took. I went to my manager. I said, "I'm going to develop open source web services on the nonstop." He said, "Dave, do it. Go for it." So I did a POC, incorporated Java, CXF, JToolKit, and we deployed on the NSJSP. With these JToolKit APIs, you need to talk to a database or an inscribed file or a pass send request. So you take your DDL, your existing DDL that represents that inscribed table, and you run that DDL through DDL to Java, and you give it a class. Now that class can be used to, you populate that data in that class, and then you pass it to those API calls, and they'll take that data and marshal it out into a byte stream that you can pass, that'll go across a pass send request. So did that, worked beautifully, no problems, no hitches, nothing. We finally get into, so we're going to go forward with open source web services on the nonstop and for this paper reimbursement thing. And the moment we were given the DDL, you run it through this DDL, the Java program, and it creates a 25 megabyte Java class. And if you try to put, if you ever played with Eclipse and you try to put 25 megabyte class into Eclipse with the default settings, it crashes Eclipse. So Nonstop managed to crash Eclipse on me. Not off to a good start here. The panic was kind of setting in at this point because there was a delivery, it was like a 4-week delivery window for this thing to QA. So you go to HP and they say, oh, upgrade. That's their usual reply. Upgrade to the latest version. Okay, sure, did that, hoping for the best. It created an 18 megabyte class. I said, okay, this is not going to go anywhere for us. So, you know, this is a nice thing. So I say JPathway. So give this with one hand, take with the other. But JPathway has the flexibility to just give you back this big byte buffer, and then you can parse it the way you want to parse it. So if you're looking at those calls, you'll see that they accept the IO classes that you create with, and they also will handle just byte buffers. So that was good. So open source development is very easy. If you've ever worked with Eclipse, you'll know that it's hard to actually use a compiled language because all your classes have auto-completion. So if you bring in a class into your library, you don't know the methods in it, it will complete those methods, give you all that information. And of course, inline syntax checking. So there's no compiling. It compiles your code as you're typing it. Which is also 1,000 times better than compiling. And there's lots of help online. I mean, you cannot exhaust the number of examples and tutorials and so forth on open source development. Open source development on the Nonstop is no different. I kind of interspersed some kind of helpful tips here. I have more at the end. But in this case here, I'm saying you got to close your files. You got to close the files. So if you open up an inscribed file, you have to somehow close it because the moment you undeploy the application, that opener is out there. It doesn't go away. So you deploy the application again. Your code executes that same open. It'll open another time. So not immediately obvious when you're developing source web services on NSJSP containers, but that's what's going to happen. This is where the serverlet lifecycle business comes in. So when you undeploy the application, there's a destroy method that you can invoke, and that's where you typically would do those closes there. Another neat thing, and maybe I'm going to say this is probably somewhat unique to the Nonstop environment, is that so the JVM has many system properties in it, and one of the most useful one is NSK process name, and why I say it's kind of unique to the Nonstop environment because we bring up multiple process. We bring up multiple NSJSP containers. And when you deploy your applications, those multiple containers will get deployed with this web service. So you'll have two $XYZ processes, ABC, 1, 2, 3, XYZ, whatever, that get that web service. So when you see requests, if you don't do something like this, all of those requests will be in the same log file, the log4j file, and so it intersperses them, so it really makes it difficult to read system. So this is a Log4j. If anybody's played with Log4j, this is definitely it's an important thing. So today, 11 NSJSP hosted web service where we're at today. Okay. Anything else? Nope. Okay, I'm going to very quickly go through this because we're up to 31 minutes. So here's our stack, Java 6 and 7, 32 bits. One gives you 1 megabyte of memory. If you go to 64, I think you get 4 meg. Don't quote me on that. Eclipse. If you've anybody done remote debugging on the nonstop with Eclipse, beautiful. It's a really nice environment to work with. Git, we use Git for our repository. All of this stuff. So basically all of this stuff has nothing to do with the nonstop. Maven, nothing to do with the nonstop. Maven is your build and dependency management. So you pull in various jars, like with Java development, you're pulling in a lot of different jars from different places. And so Maven is the tool for managing those dependencies, managing the versions that your application is working against. Spring for dependency injection. CXF is our framework for web services. It supports REST and SOAP. NSJSP is the container. I'd love to do a demo, but if anybody wants to see any of this stuff in action, I can show. Can't do it here. Dozer. No one's probably ever heard of Dozer. Maybe Phil has heard of Dozer. I don't know. No. Dozer is a mapping framework. I put a sad face beside Dozer because the I/O classes that HP creates don't play well with Dozer because these I/O classes. Someone should maybe, if I would recommend to HP, is take a look at how you're generating this stuff because it doesn't look like true or good formed Java code. NetBatch. So we're using NetBatch to schedule jobs. So NetBatch to tackle to shell, and there's a little trick command. If anybody's maybe someone's used that before, but I can show that one later. JToolkit, as I mentioned, these are all the APIs for Inscribe. We do all of them. Inscribe, PassSend, Process IPC. We're running in production, well, except for Process IPC, we have those in production. The Process IPC one is in our November release. JNI, which is the way to get into C code or from your Java application. So we do things like execute operating system procedures, and we have a tie-in to the EMS, so you can get your Java application and can write to the viewpoint or the EMS system. We use SQLMX, JMS, Java Messaging Service. It's an API for reliable queuing. If you're doing JMS and on the nonstop, and you're talking to a Oracle database, you want to run a background thread to monitor for a possible hung JMS send. I won't tell you all the gory details and expose our dirty laundry on that one, but Oracle has let us down already. That's all I can say. GGS. So we embed the GGS library for the JVM to do non-audited file replication. If you're on, I don't know if people use GGS. Probably a lot of people in here use GGS. I don't know if anybody's still on GGS 9. I mean, I think we're really behind on that one. But if you want to do replication, you can only use the Java 6 for it. It's not supported in Java 7. Okay, so next phase, Pickles Pathway Server, our Java server development. Okay, so beginning in 2014, there was a big push for integrating the non-stop with a lot of WebLogic systems. So in this world, we were envisioning where when the claim comes in, we could branch out to various services to augment that claim information either before the claim or after the claim. So that was the genesis for Pickles, and Pickles is the PDD Interceptor Chainable Logic Server. PDD is also an acronym for Pay Direct Drug. So it's an acronym inside an acronym. So what we're doing here is we're intercepting every claim from the pharmacy, every transaction. It's a Java pathway server. So the only real differences is you're running a JVM, and instead of a Guardian type process, it's an OSS type process. We use the same COBOL IDS. So the IDS is just basically an intelligent device port. So it's a red manager into the pathway environment. So essentially, we used to point to all of these different drug-related servers. Now we just point to the one Pickle server. And so, but like when you're reading the manuals and you say, well, can a COBOL program talk to a Java server? It's not. When I was looking at this, there's nothing in the literature about that, but it's just another server that listens on dollar received. So go ahead, it works fine. So we put this in place, and then it actually added no discernible impact into our monitoring of processes and monitoring of transaction times and resource utilization. So there was absolutely no overhead that the people that look at these things could detect. Okay, so Pickles is a decorator. The original Gang of Four. Anybody heard of the Gang of Four? I want to see hands for this one. Gang of Four, two people. Okay, design patterns are when you start to get into object-oriented development. Design patterns are one of the neatest things because they solve. They're a solution to common problems. And the moment you start to look at the various design patterns, you say, geez, I can use that for this, I can use that for this. So they're definitely something that, as a non-stop crowd, you miss because you're not doing object-oriented programming much. So anyways, the design pattern is a component class, and in our case, the component class is the drug request. So we package up the drug request into this component class. Then we have decorator classes, and so these decorator classes encapsulate a single logic, single unit of logic. We string these decorators together, and we create all the combination of these decorator chains. And then when a claim comes in, it says, oh, I have this characteristic for this, and it says, okay, I need this chain. So that's how it's executing. All of the decorator chains, all these objects are created in Spring. So when Spring comes up, it instantiates all these chains, so there's zero class instantiation coming in for for executing these paths. So that's a strategy for just not adding, preventing any overhead in the Java world. So Pickles went on to provide that integration with the web services and the GMS services that exist in the WebLogic world. Pickles was also our first application to use SQL-MX. And I'm interested for tomorrow's session with, which is the guy from SQL, the SQL guy. So we've got a few questions for him. Extensive use of JToolkit conversion routine. So if you look at the J Toolkit, it has a ton of these conversion routines where you can take data elements in Java and convert them to byte variables and build out a byte buffer. We use a lot of those. So the big thing now is that we've gained a lot of notoriety for the nonstop in TELUS, where it didn't exist before. When I started, I didn't know who the architects were. Didn't know them. They never talked to us. Now they're actively engaged in the applications that we're building out on the nonstop. We have CTO and VP awareness of what we're doing. Probably it was not sexy enough for them. So anyway, and then as I mentioned, we're driving solutions to the nonstop today. So now let's get to today's challenges, which is sort of the culmination of the cucumber part. So velocity and disruption, I suspect people have been facing these, their managers are saying, we got to do things faster. And if we don't do them faster, someone's going to have us eat our lunch on us. So this is the answer that you'll hear about this is shifting left. And shifting left means basically testing early and testing often. It involves some form of test-driven development and or behavior-driven development if you want to go a step further, and that's what cucumber is. It involves continuous integration and continuous deployment. I have here a note saying nonstop dependencies have consideration. So when I talk about continuous integration and continuous deployment, I don't think of that on the nonstop system. I think of it's going to exist in the your corporate infrastructure somewhere else. So if you're building applications on the nonstop, in Jenkins, you got your applications in Git. You check them in. Your Jenkins server picks up your Git changes, builds those applications. All of this can be done outside of the nonstop. Now you have to get that application to the nonstop. So the scripting, that's where I say the nonstop has a certain wrinkle. Because so now you have to deploy that application to your dev server or your QA server or what have you, and then you can run those automated tests. And that's the key. Those tests are going to prove or disprove your build. And so automated testing are JUnits and SOAP UI. I'm going to try to explain JUnits is basically self-explanatory, but SOAP UI wouldn't be my SOAP. I'm going to try to explain that in a bit. I'm definitely running behind here, right, Jack? Am I running a bit behind? Okay, we're good. Okay, QA collaboration is basically a part of this, and I'll talk a bit more about that. Agile is also, and people have been mentioning Agile, Scrum or Kanban. This is a very difficult thing to get started in an environment where waterfall is just the way everything is done. The only thing, so everybody struggles with this, and the only thing I can say is on some latest stuff is that Scrum, it seems to the feeling about Scrum is that it is you never can do it truly. It never gets implemented in the truest form. And so it turns into this less efficient way, and almost you're probably better off sticking with waterfall. That's sort of the vibe I'm getting. But now someone recently told me that Kanban is the solution to that. So I don't know. But it's supposed to get past some of those challenges with Scrum. So what is BDD? So behavior-driven development. Framework is basically a framework for collaborative development automated acceptance testing. I say it is the shift left enabler. It's the process or the framework or the for moving your testing early on right up into the development phase. Tests or features are written in a natural language in conjunction with the BAs, the developers, QA, and this is if you've ever look at the documentation on Cucumber, they call it the Three Amigos meeting. Feature files consist of scenarios written in this annotation. So there's this given, when, then annotation. And then I say Scrum user stories have one or more features. So as you can see, that implies very agile. This is an agile implied framework or process. And then Cucumber is, I don't think it's the only BDD framework, but it is probably the most popular BDD framework. This is a sample Cucumber feature file. So you actually code these feature files in your project in Eclipse. And so you'll have a feature, name the feature, a scenario. I'm going to submit a claim, and I'm going to get 100% coverage. I'm going to prove that 100% coverage works. Given this group XYZ exists and a primary certificate exists, and I submit test claim 1, the patient pay amount will be 0. So those are the things you're going to write a bunch of these things to prove all of the business logic that exists in your application. Feature files is interpreted by Gherkin. So, and that produces your Java step definitions. And with those step definitions, you start to write your test logic. And that's where, so this is early days for us, still in this regard. So in those step definitions, what you want to do for us, and I can talk about this to anybody later, is the vision that I have for this is to include the SOAP UI requests in there and get the responses back and validate those messages back and forth. And so you can, because we have so many web services, we could set up an environment, adjudicate a claim, and verify all of this stuff. So that's where we're kind of going with this. And that, of course, this all is going to run in your continuous integration platform, your Jenkins. Okay, so this is the part of the presentation where I'm just going to dump a bunch of stuff on you here that we've done on the side. So we've done Spring MVC. So build a web application with a GUI front end, deploy it on an SJSP, talk to a SQL MX database, done it. Java calling COBOL, done it. Java calling COBOL, calling Java, just because we wanted to see if it could do it, and you can do it. So you're probably wondering, why would you do all of that? Why would you have Java calling COBOL, calling Java? Well, there's a reason. If you want to talk, if you come to me, if you want to know why we would do something like that, quite interesting, and it opens up an entire new world of possibilities. Spring Boot. There has been discussions about microservices in the previous presentation. We've done Spring Boot, and it basically you're going in the nonstop context is a Java pathway server. REST front end. Jetty. Jetty is if anybody's heard of Jetty, it's the TCP/IP layer, listener layer that you can bundle in with your Spring Boot application. So this is a huge, I got a huge topic here. So it is a very huge topic. This is where a lot of people are struggling with how do you take your legacy applications and make them into microservices. And once you're in the microservice, you can get into containerizing. But I say pathway, and I think Justin has mentioned this, is that pathway, and I agree with it, is the original container manager. It is really, it's really bizarre how closely these technologies that are coming out today are really what happened for 30 years. Protocol buffers. Anybody heard of protocol buffers? Anybody? That one? No? Oh, okay. This is another microservice-related technology. It's a way of tying together microservices, and it's very fast. So we demonstrated a Linux system sending a very simple message to a non-stop in the late round, so 20 milliseconds to get that across. So it's another microservices, system integration, possibilities there. Tidbits of understanding. Okay, so very quickly, because I'm really running out of time now. ITP web server, we've encountered not a lot of issues again, but with our NSJSP web service, we encountered a chunking protocol issue. So when you have really large messages, TCP/IP will break them up into chunks and send a chunk and get a response. We were hitting a scenario where both sides would be waiting for the other to respond. No clue what was causing it. There was no explanation. So the only thing we could do, we went to HP, and they say, well, you're going to have to run a trace. So we try to catch it in a trace. And so we started that, and then it just kind of disappeared. I don't know what happened to this problem. It just disappeared. It went away. It took care of itself. I'm glad. But it was infrequent. It was very serious. In the ITP web server, there's this parameter called max request body, and it dictates the size of your XML message or SOAP message that can come into the system. Didn't had a clue it existed until someone started to send a message greater than 128K into the web service, and it's like, oh, there's a limitation. Okay, so something to think about if you're, it took a long time to actually encounter this problem, but because 128K is a fairly large message. Anyway, Java, I say it performs great. I think you have to have a D mindset. I'm old school. That's probably my old school thinking. But if you're developing, you could probably more easily develop really bad Java code than you could do with C or COBOL. It's more difficult. But Java, you have to. I think if you ever start on that, have that C mindset. We included a caching framework from the outset, so when the applications come up, they're populated with a whole slew of objects that they can just pull from a cache. Nonstop can't perform true lightweight threading, can't run threads on separate cores, so that's basically, a lot of people probably don't know that, but HP does talk about it. But I don't know if that is anybody familiar with the X platform here? Does it still exist in the X platform? No? Okay. Maybe a question for someone here, Jack, I guess. Yeah, okay. But yes, so in a Linux environment, you start a thread up. If there's another core, it'll run it in that core. Threading, as soon as you get into the NSJSP, it's a threading environment, lightweight threading environment, and even seasoned Java programmers have a challenge dealing with lightweight threads and data clobbering, data from one request, clobbering data from another request. Again, because all of our stuff is single or heavyweight threading pathway, in the traditional nonstop world, you don't encounter this. We're using SQL MX. Like going in, don't have some illusion that it's faster than inscribe for a single read, but it's not. But it's difficult to compare the two. Greg, who I mentioned earlier, he's got a lot of experience in SQL MX, so we've had some conversations, and I think that there's still definite advantages to rolling out SQL MX solutions. One interesting thing about SQL MX in 3.3 version, we used to inject our SQL MX data source properties into the JDBC Spring JDBC framework template framework class, and it stopped working in 3.3. So we called another example of the Global Nonstop Help Center. We called them, and they said I opened my mouth. I said, "Oh, by the way, we have a solution." And so they basically hung up the phone. No, not so much, but they said, "Oh, good." They didn't have to do anything on that one. Web services. So just a general statement about web service development, include validation. If someone says to you, you don't need to do validation on your web service, well, that's fine for that person, but you never know who's going to ask to use that web service. And then they'll want you to validate because they're not going to do it. So, and that's sort of the next statement is, put that validation as close to the target as possible. If it's a nonstop is hosting a lot of web service, the target may be in a scribe file or a SQL MX. So you're the closest to that target. Okay, NSJSP web services. The moment you start looking at those, you'll see this servlet.config file. That guy is going to see a lot of changes. You add the number of servers that you're going to run. If you're including additional stuff, additional libraries in the class path, that's where it's going to go. If you're calling, say, a COBOL application or module, you need to bind in that object that goes in the lib path. Don't start NSJSP servers dynamically. Totally different kettle of fish. So you have to specify max servers 2, num static 2, if that's what you want. DDL, again, I've talked about this. It's going to create your WSDL. It's going to be the starting point for your WSDL creation. And also, you're going to generate your IO classes based on the DDL. If you change these DDL files, because this is nonstop generated code, if you're going to change those, you could likely break something because you just forget. So you change it, and then someone changes the DDL, so you regenerate the DDL. You overwrite that version that had a unique change. So you need to have a robust procedures around that, or if you go into continuous integration, it'll find these things earlier. So you're going to run these tests. We've actually encountered that. We stored in Git. Yes. Our DDL. Good question. Anything can go in Git. Staffing. I think I'm very close to the end. Okay. So staffing. So easy to staff. Nonstop. This open source stuff. You don't need nonstop experienced people. In fact, you just need Java. Like if you're developing Java, a seasoned Java application developer. So we have onshore folks, we have nearshore folks, we have offshore folks, and so we do it all. And really, one thing we've found is that if you come from a pure COBOL background, it could be very challenging for that individual to adopt or start working in this framework. It may have been, just this one case, but I think having, if it's pure COBOL, I think it could be a challenge for some people. You need an assertive mentor, someone who understands nonstop, the fundamentals, and they can communicate that to the people that have no experience with nonstop, because you really don't need experience with nonstop when you're in this world. the naysayers of my favorite. So if you are embarking on this, you probably will encounter a naysayer. The person who says that is, they're basically this individual, any kind of change is a bad thing. So, and in the nonstop world, I've heard it is sort of a common theme in places where they're trying to do stuff like this. And so my advice is ignore those people. Become that disruptor in your team. Okay. Question. Did I overwhelm everybody so thoroughly? A question. Thank you. Oh, that. Those are. You can see. You guys will get this slide, but this is just. If you want to, this is a good video on Scrum, but I'm going to say now that maybe you want to skip this one and go look at Kanban. Yes. And this multi-part sessions on Cucumber, this is very comprehensive. And if you're really interested in Cucumber and this whole BDD, there's a book called Java for BD or Cucumber for Java for Cucumber, and it's probably the ultimate Bible for this topic. I have a copy of here. I brought a copy with me if you want to take a look at that. But it's a really good book on Cucumber and BDD. No questions. Nothing.
Okay. Well,
I guess how far over did I go?
Like I say, we're pretty much out of time.
Okay. Okay.
So thanks very much, David. It was excellent. So just quickly.